Hello students, you are welcome to this class. In this class we are going to discuss a relation function, the continuation of relation function, session number 4. Let us discuss example problem as well as exercise problem from the chapter. We will start our discussion. It's part number 4. This is from exercise 1.2, second question. Check the injectivity and surjectivity of the following functions. We are already discussed first 4 subdivision of this question. Now we'll discuss fifth subdivision of question number 2. The mapping and from set of integers to the integers given by f of x equal to x cube. If we take the mapping f of x, we take the mapping f of x is equal to x cube, and the mapping f mapping from set of integers to a set of integers. That means here x belongs to integers, and we have to confirm the validity of injective nature, that is one-to-one function, surjective nature, that is on-to function. For one-to-one function, two equal image should have equal pre-images. We have to show that. Let us start our assumption. Let f of x1 and f of x2 equal. Here x1 comma x2 are integers. It can be positive integers or negative integers. Then according to the mapping f of x1, x1 cube and x2 cube, and taking both the same side, x1 cube minus x2 cube is equal to 0. On further factorization, x1 minus x2 and x1 square plus x1 x2 and plus x2 square. Okay, is equal to 0. In this case, both x1 x2 are positive number or x1 x2 are negative numbers. Then the x1 square and x1 x2 and x2 square cannot be 0. This cannot be 0. Okay, and x1 minus x is only one possibility to be 0. So x1 minus x2 is 0. This implies we can have x1 equal to x2, and where x1 comma x2 are integers. Now we can conclude that mapping f is injective. And to confirm or to test surjective natures onto function, the image is a cube number mean, then x may not be always integers. For example, let x cube equal to 2. X equal to 2 and 2 is nothing but y belongs to integers, and this implies the corresponding pre-image. and pre-image of 2 and pre-image of 2, that is x equal to cube root of 2. The cube root of 2 is not an integer, does not belongs to z. Therefore, every y belongs to y that does not exist an element x belongs to x, that is codomain, and such that y equal to x cube. Therefore, we can write the function f is not onto. What is another name of onto? Is not surjective. Is not surjective. Next question, prove that the greatest integer function f mapping from R into R or set of real numbers and codomain also a set of real numbers given by f of x equal to greatest integer function is neither 1 to 1 and nor onto, where the square bracket x denote the greatest integer function. So we can show the violation in case if we take, let f of 1.1 and 1.2, we can take the other way. Let 1.1 is not equal to 1.5, but f of 1.1 is equal to f of 1.5 and both 1. So this shows that the function f is not injective, that is 1 to 1. The function is not injective. Okay, very important. Then the second case, onto function. What is the range? Range is a collection of all integers. That is range equal to z. Z is a subset of the codomain R. So in the codomain, your codomain is not equal to a domain. Is not equal to domain. Codomain is not equal to not domain, range. And therefore the function, it is not surjective. Now we can conclude the greatest integer function is neither injective nor surjective. Is not surjective function. So integer function is not surjective. That's enough. So go through it. Show that the modulus function f with the domain set of real numbers and codomain also set of real numbers given by f of x equal to mod of x is neither 1 to 1 and nor onto, where mod of x is x is positive and 0, or x is mod of x is negative if x is negative from the definition of modulus function. It is a well-known fact. Actually, mod of x equal to minus x if x is less than 0 is plus x if x is greater than or equal to 0. X equal to 0, mod of x equal to 0. Okay. For 1 to 1, that is surjective. For the test of surjective nature, and 1 is not equal to minus 1, but and mod of 1 and mod of minus 1 equal. And mod of 1, mod of minus 1 equal to 1, and this implies what is mod of 1? F of 1 and f of minus 1. So two different pre-images have equal image. This is a violation of injective nature, and therefore the function f is not 1 to 1 or injective. It's not 1 to 1. For onto function, and f of x equal mod of x equal to minus x if x is less than or equal to 0, mod of x is x if x is greater than or equal to 0, and f of x equal to mod of x is equal to minus x if x is less than 0 and plus x if x is greater than or equal to 0. This implies mod of x is greater than or equal to 0 for all x belongs to R. Therefore, what is range? Range equal to and positive real numbers including 0, non-negative. X is greater than or equal to and f of x is greater than or equal to 0. This is subset of the set of real numbers. That means range is subset of codomain. A range is not equal to codomain. Now we can conclude the function f of x, that is absolute value function with the origin 0, is neither 1 1 nor onto, with the mapping and f mapping from real number into real number. Okay, this because of the mapping, instead of the codomain or only positive real numbers mean or non-negative real numbers mean, we can conclude this not 1 to 1 but onto. And because of the codomain entire real numbers, a range is a subset of codomain. It is not surjective or it is not onto function, and therefore the modulus function for the given mapping is neither injective nor onto or nor surjective. Then show that the signum function is a familiar question. Signum function f mapping from R into R given by f of x is 1 for x is greater than or equal to 0, and this is familiar graph. This y axis is x axis, is a graph of the function. And x value is less than 0, and x is greater than 0. Here x is 0. X is 0 means the value is 0. Then x is less than 0 means and y equal to minus 1. X greater than 0 means I think the totally the graph should be changed. Is x-axis, y-axis. X is greater than 0, y equal to 1. Is y equal to 1. X is less than 0, and y equal to minus 1. Here x is less than 0, x is greater than 0, x equal to 0, and y equal to, that is this value 0 will come. Y equal to 0. Here nothing. Okay, so based on this signal function and graph or graphical representation, we can conclude easily. And f of, from the figure, f of 1 and f of 2 is equal to 1, but the pre-images 1 is not equal to 2, therefore f is not one-to-one function. F is not injective. F is not injective, and the range is collection of images. So -1, 0, 1 is subset of real numbers. The real numbers is codomain. So range is a subset of codomain. We can conclude the function f of x, the signal function, is neither injective and nor a surjective. Neither injective and not subjective. Subjective. Okay, we have to conclude that the function is neither injective nor subjective. It is not one-to-one as well as onto. In this question, set A 1, 2, 3, set B 4, 5, 6, 7, a function 1, 4, 2, 5, 3, 6 given from A to B, and so that the f is 1 to 1. What is the function f in roster form? 1, 4, 2, 5, 3, 6. Okay, so 1, 4 and belongs to f mean f of 1 equal to 4. This implies f inverse of 4 equal to 1. and 2 comma 5 belongs to f, this implies f of 2 equal to 5, this implies f inverse of 5 equal to 2, as well as 3 comma 6 belongs to f, this implies f of 3 is equal to 6, this implies f inverse of 6 is equal to 3. This shows that the pre-images are unique for every image. Unique for every image. Every image B belongs to the set B. Yes, every pre-image is A, and therefore the function f is one-to-one or injective function. Very important. To confirm the function is injective or one-to-one mean, check the pre-images. For every image, the pre-image is more than one mean, it cannot be one-to-one function. The pre-image is unique, the function is one-to-one or injection type of function. In seventh question, in each of the following cases and state whether the function is one-to-one or onto or bijection, and we have to justify our answer. Subdivision 1, the mapping between real numbers and defined by f of x equal to 3 minus 4x, a linear function. Let us take f of x1 and f of x2 same. What is the image of x1? 3 minus 4x1. Image of x2, 3 minus 4x2. Now we can simplify, we can cancel 3 on both the sides. Minus 4x1 will be equal to minus 4x2. Now divide by minus 4, we can get x1 equal to x2. That is equal pre-images. For equal images, and therefore f is 1-to-1. 1-to-1. Now we have to test onto nature. For onto, we should find a range. We should find a range and codomain, and both real number mean we can accept. But what is the method? 3 minus 4x is a function. So let for onto justification, let always you have to assume y equal to f of x. Y equal to what is f of x? And 3 minus 4x. Now, and this is explicit form of real function. Y is written completely in term of x, means explicitly separated. Explicitly separated means the complete y variable one side, a complete x variable another side, wherever the clear separation occur between the two variables x and y. This type of function is explicit type of function. Now we have to write x in term of y. So 4y will be equal to 3 minus y, and y equal to 3 minus y by 4. Again 4x is equal to 3 minus y. X equal to 3 minus y by 4. X pre-image. Pre-image it belongs to range. So x is a real number. X real number means 3 minus y also real number. And this implies y also real number. Y real number means and range is equal to real numbers is equal to codomain. As range equal to codomain, the function f of x is equal to 3 minus 4x is 1 to 1 and on to is 1 to 1 and on to function. Okay, and we have discussed one more question. What is the question? 1 plus x square. 1 plus x square you have to take it. So f of x equal to 1 plus x square. The given mapping f mapping from real number into real number. Actually this is parabola, open upward direction. What is the relevant graph? What is the relevant graph? Is x-axis, y-axis, x-axis, y-axis. When x equal to 0, y equal to 1, this is vertex of the parabola and open upward direction. Actually this is a graph, and we know that parabolic real function is not one-to-one function for two different values. For example, we can take and 2 is not equal to minus 2. Okay, and what about f of 2? 1 plus 2 square is equal to 5. And what about f of minus 2? 1 plus minus 2 the whole square equal to 5. Then this implies f of 2 and f of minus 2 equal, but pre-images are unequal. So for different pre-images, equal images. So different pre-images give different pre-images give equal image or same image. Equal image. And therefore the function f of x is 1 plus x square is not injective. Is not injective. Now we have to confirm and whether the function is onto or not, surjective or not. And because of x square always positive, f of x always positive, f of x will not take no negative numbers. And what is the least value of x1? So what is range? A range 1 to infinity is a subset of real numbers. So range is a subset of codomain. What is real number? Codomain. Therefore the function is not onto. So this particular function is neither one-to-one nor onto function. Clear? Next question. Let A and B be two sets and show that the F is a mapping between two Cartesian product. A cross B is a superset of domain. A cross B and superset of domain, but function given means A cross B is a domain. If it is relation superset, A cross B is a domain and B cross A is codomain. Is codomain. And what is the mapping given? The image of the pre-image A comma B is a mirror image B comma A. Mirror image B comma A. And we have to show that this bijection is 1-to-1 as well as onto function. 1-to-1 as well as onto function. So let us take for 1-to-1, let us assume with the two different images. Let f of A comma B is equal to f of and C comma D. Clear? F of A comma B is B comma A and f of C comma D is D comma C. D comma C. Then f of A comma B, f of C comma D, then B comma A equal to D comma C. But we have to show that and A comma B and C comma D are equal. Okay. And the Cartesian product f of A comma B, B comma A and two sets, but A comma B mean 2 comma 1 and how to prove using this method f of A comma B equal to f of and C comma D. Yes, we have to think. And these two are equal mean B1 and D1 will be equal. And A will be equal to C. From the law of ordered pair, then A equal to C, here AB, BC and CD. I have taken some other way. So here little problem. F of A comma B, B comma A. And f of B comma A comma B. This means A equal to B or B equal to A or A equal to B. B equal to A equal to B mean definitely A comma B equal to B comma A. A comma B is equal to b comma a. Why a and b are equal? So what is the pre-image of f of a comma b and a comma b? Pre-image of f of b comma a, b comma a. Because of this, we can conclude the function f is 1 to 1. The function f is 1 to 1. For onto function, and the image actually f of a comma b equal to b comma a for all a comma b belongs to a cross b. That means the b comma a belongs to b cross a. Then this implies the b comma a belongs to b cross a. So this implies and range equal to b cross a. Then b cross a is codomain, so range equal to codomain. Therefore it is onto, and therefore and the function f is an bijective function. Bijective function. Yes, f of a comma b equal to b comma a mean, and a comma b pre-image, a comma is a pre-image of b comma a. Then what is image? The collection of, that is, what is range? A collection of image. The range is nothing but b cross a. So b cross a is codomain. Codomain and range equal mean it is onto. Already we have proved it is 1 to 1. It is 1 to 1 as well as onto. So the function is bijective function. The function is bijective function. The next question is the function mapping from natural number into natural number, and f of n for n odd number and n plus 1 by 2, n even number n by 2 for all n belongs to natural number, and state whether the function f is bijective and justify your answer. Okay, what is the question? F of n n plus 1 by 2 if n is odd, n by 2 if n is even. Okay, let us start with the assumption f of n1 is equal to f of n2. And case 1, n1, n2 are odd natural number. n1, n2 are odd natural number, or odd positive integers. Odd positive integers nothing but odd natural number. Then let us assume what is f of n1? n1 plus 1 by 2. Then f of n2, n2 plus 1 by 2. After simplification, we can get n1 equal to n2. And case 2, n1 comma n2 are even and integers, even positive integers, or even natural number, even natural number. If n1 comma n2 are even natural number, what is f of n1? n1 by 2. F of n2, n2 by 2. This implies n1 equal to n2. Okay. In the third case, and n1 is odd and n2 is even, then f of n1 is equal to odd mean n1 by 2. What is n1 by 2? Odd by 2, odd number by 2. So odd number by 2 cannot be even number. Cannot be even number. Other than n1 by n2 and does not belongs to n. n1 odd number mean what is the condition? We check the condition. n1 odd number mean n plus 1 by 2, no? So here instead of n1 by 2 we have to take n1 plus 1 by 2. Odd number plus 1, even number by 2, even number by 2, and 2 by 1, 4 by 2, and 2 by 2, 1, 4 by 2, 2, 6 by 2, 3. So this is natural numbers. What is f of n2? F of n2 even number, then n2 by 2 belongs to n. So whenever n1 and n2 different, or we can show example. What is the example? Let us rub the whole thing. F of 1 equal to 1 plus 1 by 2. F of 2 equal to even number means 2 by 2 equal to 1. This implies f of 1 and f of 2 are equal, but 1 is not equal to 2. From the third case, it is not. From the first two case, 1, 2, but third case, because one violation enough to reject the 1 to 1. So the function f of n is not injective. Is not injective. That is not 1 to 1. It's not 1 to 1. And to test onto, and what is the function? F of n equal to n plus 1 by 2 if n is odd natural number, n by 2 if n is even. Okay. Now let m equal to f of n. M equal to f of n. Then we should find n in term of m. And case 1, n is odd number, and case 2 n is even number. Case 1 n is odd number, case 2 n is even number. Let n is an odd natural numbers. Then m equal to f of n. Then what is f of n? N plus 1 by 2. Then this implies n equal to 2m minus 1. So n odd number means m can be any natural number. Whatever natural number given to m, then n will be odd number. And n is even natural number. Then m equal to f of n. Because of even natural number, f of n equal to n by 2 equal to m. This implies n equal to 2m. N even natural number means then m can be any natural number. So m can be any natural number means what is range? Range equal to natural number. So this implies range and that is set of values of m. What is m? F of n. Is equal to natural number. And codomain also natural number. As range equal to codomain, the function f of n is onto but not 1 to 1. Therefore, it is not a bijective function. It is not a bijective function. Clear? Let A set of all real numbers other than 3, B set of all real numbers other than 1. Consider the function f mapping from A to B. F of x equal to x minus 2 by x minus 3 is f 1 to 1 and on to justify your answer. So what is the given mapping? F mapping from A r minus 3 to r minus 1 and given by and f of x is equal to x minus 2 by x minus 3. To confirm or to discuss 1 to 1, let us take f of x1 and f of x2 equal. What is f of x1? x1 minus 2 by x1 minus 3. The other side x2 minus 2 by x2 minus 3. Just cross multiply x1 x2 minus 3x1 minus 2x2 x1 x2 minus 2x1 minus 3x2. This and this cancel. Then minus 3x1 here minus 2x1. So after rearrangement we can get x2 equal to x1 or x1 equal to x1. Therefore we can conclude the function f is 1 to 1. Now we have to find the range. The range equal to set of all real numbers except 1 mean range will be equal to codomain. Then you can confirm the function is onto also. F of x equal to x minus 2 by x minus 3. Let y equal to x minus 2 by x minus 3. This is explicit function of y in term of x. We should convert as explicit function of x in term of y. After cross multiplication, x into y minus 3y equal to x minus 2. Take x term one side, xy minus x equal to 3y minus 2. Now we can write x equal to 3y minus 2 by and y minus 1. Y minus 1 and x is a real number mean a real number other than we have tested real number other than 3. The denominator should not be 0, so y is not equal to 1 and y equal not equal to 1 means this implies y belongs to entire real number except 1. So this is nothing but and codomain. So range equal to codomain. Therefore the function f of x is 1 to 1 and to onto function. We want to test the statement of the question once again. Justify your answer. Justified. Okay. Listen now, and we have to learn the composition of function and invertible function and its property and problem. So this discussion will be continued in the next class. To be continued. To be continued, and from the composition of function and the invertible function is the next class discussion. Next class and class number 5. So my dear student, in this session we have completed exercise problems 1.2 and we solved all those problems related to the types of the function, one-to-one function and onto function. A function which is one-to-one onto is known as bijective function. Once after learning the composition or composite function, the identity function based on the composition function, we can introduce the invertible nature or invertibility of a real function. Once we knows all the concept related to invertible function, and we can discuss the existence of inverse function only in the next session. And thank you, students.